We've taken our time with three-dimensional geometry, volume and surface area. We've taken our time with area of simple shapes and area of irregular shapes, cutting them up and finding an area. What we want to take a look at in our next unit is angle measurements. And you guys have dealt with angles before. Just so we're clear, there's a couple different kinds that you can have. You can have an acute angle. Acute angle is less than 90 degrees, smaller than the letter L. You can have a right angle, which is exactly equal to 90. You can have an obtuse angle, which is greater than 90. And the last kind you can have is a straight angle, which is exactly equal to 180. Smaller than 90, equal to 90. Bigger than 90, equal to 180. We want to specifically take a look at what they do in triangles. So that if you remember, there are three types of triangles, and we're going to talk about side lengths, naming triangles by that. In this triangle, which is an equilateral. Now, if you remember this or not, equilateral means that all three sides are the same length. All three sides equal length. Now, how can I show that they're all the same length? Yeah, I could measure it, or I could put a 10 here, a 10 here, and a 10 here. What if I don't know the number? How do I show that they're all congruent? Remember, congruent means equal. What if I put a dash here? I can take that same dash and put it here. This dash is congruent to this dash. That side congruent to that side. If these two sides are equal, so is this side. Now, what's interesting about an equilateral triangle, not only are all three sides equal, but you're going to find a quick pattern here with the others is, if I have three equal sides, I'm also going to have three equal angles. That means this angle is equal to this angle is equal to this angle. So the question is, what does each angle have to be worth? Well, if you remember from previous learning, previous years, all triangles add up to 180 degrees. They must by rule. So what's interesting about an equilateral is because all three angles are equal, they always have to be the same thing. So what number added 3 times gives me 180? Well, it has to be 60 degrees, 60 degrees, and 60 degrees. Equilateral. 3 congruent sides, 3 equal sides, 3 equal angles. In an equilateral's case, it just happens to be 60. The next type of triangle is an isosceles triangle. Isosceles means there's 2 equal sides. If I look at this picture, I can clearly see which 2 sides should be equal. This side should be equal with this side. I would not put a mark with the third side because the bottom or the third side is not congruent with the other pieces. I only want to mark off the things that are congruent. This side is equal to this side. Another way I could mark it is this. I could put 2 hash marks here. Double hash mark side is congruent with the double hash mark side. The bottom I would put as a single hash mark. Hash marks are used to identify which sides are congruent. The same number of hashes would be congruent to this same amount. Okay? So if you take a look, not only are 2 sides equal or congruent, how many angles do you think are equal or congruent? Just like in equilateral, how the number of sides and the number of angles match, so will be in isosceles. 2 equal sides, there are going to be 2 equal angles. Now, how do you figure out which 2 angles are equal? The easy way to do it is this. Put your pencil at one of the equal sides, one of the congruent sides, and go across. This angle is going to be equal to this angle. So it's always the sides opposite. I'm sorry, the angles that are opposite. Look at the two equal sides, go opposite of them, and you'll find the two equal angles, or the two congruent angles. Now let's fill numbers in. Here's what a lot of kids do. They say, oh, this must be 45, this must be 45. Because 45 plus 45 plus 90 equals 180. Well, does this look like 90? I don't think. And then I ask kids, well, what is this? And they say, it's 20, it's 30, it's 27. Do you have any idea what this is unless you measure it? The answer is no. We're not going to measure it. Instead, I'm going to put something in. What is the measure of this angle? I need a number. What is the number? You don't know. Okay, you don't know. So what can I put here to represent a number that we know is there, we just don't know what it is? I need a variable. It doesn't matter what variable you pick. Let's do m. How much is this angle? M degrees. I don't know what it is, but I know it's a number. Now, down here, let's pick a different variable. What variable do I want for this angle? I don't care. Let's use b. Now the thing is this. What must this angle be worth? Remember, isosceles has two equal angles. It's the opposite angles of the congruent sides. So if this angle is b, this one must also be the letter b. Two equal angles, two equal sides, two equal angles in isosceles. The last triangle we want to talk about is a scalene triangle. Scalene means no sides are equal. Equilateral, 3 sides equal. Isosceles, 2 sides equal. Scalene, 0 sides equal. So I'm going to make the left side 1 hash mark or tick mark. Am I allowed to make this 1 hash mark? The answer is no. None of the sides are the same. So what could I possibly mark this side as to show that it's different than a 1 hash mark? I can do 2 hash marks. What can I mark this side as? Is it the same as this and this? No, this is different too. What's different than 1 hash mark? What's different than 2 hash marks? Let's do 3 hash marks. Scalene has no equal sides, 0 equal sides, which means they're all different. Now, what does that mean as far as the angles? Now, put the pattern together. I saw equilateral, 3 equal sides, 3 equal angles. Isosceles, 2 equal sides, 2 equal angles. Scalene, 0 equal sides, how many equal angles? That's right, 0. Okay, so let's fill in angles. What's the top angle worth? A. The top angle is worth A degrees. How much? I don't know. What is the left angle worth? Well, if none of the angles are the same, am I allowed to use A again? No. So let's call that B. It doesn't matter what letters you pick, I'm picking them randomly. This angle's A, this angle's B. What must this angle be worth? Am I allowed to use A? Am I allowed to use B? Let's use the letter C. So these are my 3 types of triangles.